main problem in the development of electrostatic speaker technology has not been a lack of understanding of the electrostatic principle. Back in the early 1900s, Philco Radio built one of the first radios using an electrostatic tweeter. It had a rather poor acceptance, and it was fragile. The reason for this is not an understanding of the workings of electrostatic speakers. It had mainly to do with materials at that time, being able to work reliably at high voltages. We're talking about, as in our speakers, playing them loud. The signal voltage can attain levels as high as a peak voltage of 30,000 volts. And there were simply no materials before about the year 2000 that could handle this type of voltage reliably. Well, the reputation of electrostatic speakers was not good until Arthur Janssen developed his little electrostatic panel. And he solved one of the big problems. In the past, due to a lack of good voltage insulation, the stators were basically poorly insulated and broke down, and there was not much that could be done. But with the advent of the plastic industry, we have developed insulation now that can easily handle the huge potentials. Arthur Janssen was one of the first to use an early version of polyvinyl chloride, which did a reasonably good job. And today we use a material that has been molecularly consolidated so that there's no broken atomic problems, and the insulation is even much more capable of handling the high voltages. There are other problems that had to be faced. One happens to be the effect of humidity. There are two aspects to the electrostatic speaker. One is the audio path, which is applied to the stators, and the other is the membrane, which holds a constant, very high voltage charge. Humidity has absolutely no effect on the audio part of it. The problem comes with the membrane. The membrane must be made conductive in order to hold a charge, and optimum performance of the electrostat is obtained when the conductive surface of the membrane has a very high specific resistance, and that keeps charge from traveling quickly, and it causes the charge to evenly distribute over the entire membrane. However, since this is a high impedance film, and humidity is conductive due to contaminants, and when humidity occurs, leakage paths are created on the exposed membrane, and this can voltage divide the high voltage that's required on the membrane, and the sensitivity of the speaker drops. Well, we have circumvented this problem by using a copper foil trim around the periphery of the membrane, and it acts as a fence. Humidity still comes, but the protective copper is much lower impedance, and therefore the effect of humidity stops at that point, and the membrane is not affected by humidity as a result. In answering the question about other problems, one that came to us personally that we did not expect, in our initial speakers, things were going very well, but for some reason, people that lived on the coast near oceans were having speaker problems. And this was, I could not understand the problem. Was it due to altitude? Was it due to temperature? Well, we received some of the models back and were amazed. The membranes were coated with salt. And immediately we knew the problem. The potential we were using, the charge potential on the membrane, was would attract the salt ions, and so all we did was reverse the polarity on the membrane, and it repelled the salt rather than attracted it. Problem solved. The whole problem is this very thin compliant membrane needs to be placed in a certain geometric form with a certain tension. Now, we use mylar on the membrane. It's a very tough material that's UV insensitive and will basically last forever. It has another characteristic we've taken advantage of. When it's heated to about 300 degrees Fahrenheit, it will assume a stable molecular configuration. And we have designed the speaker such that when the membrane has been installed, we heat treated it at 300 degrees Fahrenheit. It assumes that stable condition, and everything is fine. Now, the other thing is the membrane must have the shape and tension to work properly, and that requires a very careful design of the structure that holds the membrane. It must hold it at this configuration and tension at all temperatures, at all humidity levels, at all altitudes, and this is where mechanically we've designed a structure that accomplishes this with no problems. So you can expect today's electrostatic speaker to basically become an heirloom if it's taken care of properly.